Unit 2A, Lesson 1. This will align with Lesson 8.7 in your textbooks. The standard we're going to focus on in this lesson: verify experimentally the properties of dilations given by a center and a scale factor. There's two parts to the standard. Part A, a dilation takes a line not passing through the center of the dilation to a parallel line and leaves a line passing through the center unchanged. Okay, so we're going to be working with equations in slope-intercept form. For that part, a little more algebra 1 involved. For part B, the dilation of a line segment is longer or shorter in the ratio given by the scale factor. So we're going to be using a coordinate plane. We're going to have a graphed trapezoid or triangle and seeing how the scale factor affects the size of that given shape. In this first example, line L has the equation y equals negative 1/2 x plus 4. The 4, if you recall from algebra 1, that's our y-intercept, so where we're crossing the y-axis, and the negative 1/2, that's our slope. From this point, we go down 1 to the right 2. And that pattern continues down 1 to the right 2. So we want to graph the image of L after a dilation with a scale factor of 1/2 centered at the origin. If you recall from the standard, the lines are going to be parallel. Okay, so the slope isn't going to change, and for our equation, what's going to change is the y-intercept. Okay, so we have 2 points we can focus on. We can focus on the y-intercept and the x-intercept. The ordered pair for the y-intercept is going to be 0, 4, and the ordered pair for the x-intercept is going to be 8, 0. So now if we perform this dilation, there's a scale factor of 1/2. So if we multiply each of these coordinates by 1/2, now we would get the ordered pair 0, 2 and 4, 0. So I'm going to plot these points. We've got the y-intercept 0, 2 and 4, 0. And now I can draw a line going through each of those points. Okay? And we can see that this is going to be parallel to line L that we started with. If we have a dilation with a scale factor of 1/2, all we have to do is use those two ordered pairs to find 2 points so that we can construct this new line. The equation for this new line would be y equals, the slope doesn't change, so this would still be negative 1/2 x. And now if we look, our y-intercept is 2. So negative 1/2 x plus 2. In this example, line L has the equation y equals negative 3x plus 1. Write the equation of the image of L after a dilation with a scale factor of 4 centered at the origin. Some of you may have noticed in the last example the slope didn't change, and all we essentially did to come up with that equation at the end was multiply the y-intercept by the scale factor. So we can use that same idea here. If we're starting with y equals negative 3x plus 1, we have scale factor of 4. To come up with the new equation, it's going to be y equals, the slope will not change, they're parallel lines, negative 3x multiply 1 by 4, so we get plus 4. So that is the equation for a line after a dilation with a scale factor of 4. Example 3, graph the image of trapezoid CDEF after a dilation with a scale factor of 1/4 centered at the origin. So if you look to the right, I wrote down all the ordered pairs for the vertices of this trapezoid. All we're going to have to do is multiply each of these ordered pairs by the scale factor 1/4. So f prime would become negative 1, 1. E prime would become 2, 1. D prime would become 2, negative 2. And C prime would become 0, negative 2. So now we just have to go through and plot all these points. Negative 1, 1. That is f prime. We have 2, 1. That's E prime. D prime is 2, negative 2. And C prime is 0, negative 2. So now we just have to go through and connect all of those points. So if we take our original trapezoid CDEF and perform a dilation with a scale factor of 1/4, now we get the image F prime, E prime, D prime, C prime. Okay, remember the prime helps us denote which one is the image. Example 4, the green shape is a dilation of the black shape. We want to determine what is the scale factor of the dilation. So a general formula to use to find a scale factor, K, remember stands for the scale factor, equals the length of the image over the length of the pre-image. So we just have to pick one pair of corresponding sides, determine the lengths of each, and then simplify that ratio. So I'm going to pick just the left side because those are lined up nicely. The image, remember, is the green shape because that's a dilation of what we started with. So the length of this green one, 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So K is equal to 9 divided by, now we have to take the corresponding side of the black shape. We have 8 units plus 10 units would be 18, which of course we can simplify down to 1/2. So the green shape is a dilation of the black shape with a scale factor of 1/2. The last example, write the coordinates of the vertices after a dilation with a scale factor of 4 centered at the origin. Okay, so I wrote down all the ordered pairs for the vertices N, M, L, and K. So if we have a scale factor of 4, all we have to do multiply each of these ordered pairs by 4. So that'll give us N prime to be an ordered pair of -8, 4. M prime will become -4, 4. L prime will become 4, -8. And K prime will become -8, 8. So as long as it's centered at the origin, all we have to do is multiply each ordered pair by the scale factor. Just to quickly review what we covered in this lesson, we worked with equations of lines. If we were given the equation of a line or saw the equation of a line on the coordinate plane, we could perform a dilation as long as it's not through the center of the line that is parallel to the line. Remember, the only thing that's going to change is the y-intercept. If the line goes through the origin or goes through the center, then it will remain unchanged. Okay, we did not work with one of those examples. We can discuss that more in class. Then the second part, we worked with finding scale factors or using scale factors to find the image after a given dilation.